Okay, I'm gonna go through this real quick. The stuff you need to know for the test, okay? All right, first of all, and I mentioned this a couple times as we were talking about the gas laws. You need to know inverse versus directly proportional. So remember when we look at the ideal gas law, all right? When we said like P1, V1 over N1, T1. I'm sorry, not the ideal gas law, the combined gas law. All right, and P2, V2 equals N2, T2. And remember, you do get to have a note card. The easiest way to remember inverse versus direct, if they're on the same level, right? P1, V1, that is inverse. Because when P goes up, V goes down, right? P goes, so if this P gets higher from here to here, then the V had to get smaller so it maintains a constant, all right? But if they are top and bottom, they are directly related, direct ratio, all right? Because if P goes up, N has to go up in order to keep it. So for example, if P is two, if this is 2 over 2, and P goes up to 4, because 2 over 2 is 1, then N has to go to 4 to keep it at 1. Does that make sense? All right, so on the same level is inverse, top and bottom direct. The same thing applies even if they're on the bottom. All right, the number of moles versus the temperature. Inversely proportional. All right?
Is that all we have to know about that?
Yeah.
Okay, so it's not like calculate,
No.
blah, 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 okay.
No. Yeah. As far as that, now, I mean, there are calculations
Right,
you'll
but
have
we
to
just,
do.
like, for at least that part, we just need to know that.
Right. For that part, yeah. For the part where you have to do that, then yes.
Okay.
All right. Okay. You need to know the STP conditions in both the standard and then be able to convert it to like other units, right? So if it's STP is 1 ATM, right? And standard temperature
What is
is 0 Celsius, right? Yes?
this? What does STP stand for?
Standard temperature and pressure. So standard pressure is 1 ATM, standard temperature, I'm 90% sure it's 0 degrees Celsius. Yeah, okay, 0 degrees Celsius, which would be 273 Kelvin, right? If you had to convert it, okay? Or vice versa. Standard pressure is what we use to do all our other conversions, right? So 1 ATM, 760 torr, 760 millimeters mercury, 29.92 inches of mercury, 101.325 kilopascals. All of those are still standard pressure conditions.
So what do we just need to know the conditions of it?
Yeah, you just need to go,
Oh.
cause, yeah,
So like
but I
0
think it
degrees-
asks you in multiple pressures or something like that. So you just gotta do the conversion.
Oh.
Yeah.
0 degrees Celsius.
Is also
It's also 273.15.
0.15, yeah. And again, use the conversion they give you
Right.
in the stuff at the top of the quiz, okay? All right. You have to be able to do, there's several calculations where you have to manipulate PV equals nRT. All right, that would be standard on any gas law test in chemistry. All right, so you might have to solve for pressure, you might have to solve for volume, you might have to solve for the temperature, you might have to solve for the number of moles, okay? If you know the number of moles, you might have to convert it to grams, right? We know how to do that. Or we might have to convert it to the number of molecules. Or, you know, you see what I'm saying?
The number of molecules that be in.
Well, the N is your moles.
Right.
If you had to convert it to molecules, what number, how many molecules are in a mole?
So you'd find N and you'd multiply it by 6.0.
Yep, 6.022 times 10 to the 23rd. All right? You might have to, and I'm not saying might, you will have to do one where you have to do stoichiometry, figure out your number of moles, and then plug that into, right? So, oh, here we've been doing a gazillion balancing equations things. Okay, so here, let's use this equation. C2H4.
Slide it.
Hang on, let me write this down. And 2O2 yields 2CO2 plus 2H2O. Because we're balancing equations in Chem 1. All right. Okay, so if we had an equation like this, all right, they might say at 24.0 degrees Celsius and a pressure of 768 torr, how many milliliters of O2 is required to completely burn, I don't know, 76.0 grams C2H4O2. All right? I think I got everything there. Okay, so what we would need to do, anytime you're doing something like this, I make a little chart, P, V, and T. Okay? All right, so my pressure equals 768 torr. Okay, my volume is what I'm going to try and find. My number of moles, I also have to find that from stoichiometry. That's where your stoichiometry is going to go. Oh, I'm so sorry. Yeah, all right, so there's my equation. All right, my volume is my unknown, that's my X. All right, my N, I don't know it yet, but I can find it from the data given to me using stoichiometry, and my temperature is 24 degrees Celsius, right? But remember, temperature must always be in what? Kelvin. So we had 273, so that'd be 297 K. And for what we're doing, that's fine. Don't put the 1.5. So we have to do the stoichiometry, all right, to solve for our number of moles of oxygen. Okay? So we'd start with, bless you, the 76 grams C2H4O2. Okay? And if I have grams here, where's it going to go on the next step? Bottom. And we're going to do the rough one. So we got 32 plus 4 is 36 plus 24 is 60. So we're going to say 60 grams per 1 mole. C2H4O2, right? And then we need to use our mole to mole ratio. Well, in this case, from our balanced equation, it's 1 to 2, right? So 1 mole C2H4O2 on the bottom, 2 mole O2 on the top, okay? I don't need to go any further on that on my stoichiometry because N is number of moles. Once I get there, I am good. So 76 times 2 would be 152 over 60 would be 2 point what?
2.5.
So 2.5, we'll just use that. So this equals 2.5 moles O2, all right? 760 torr, or 768 torr, we divide by 760 torr to get it to ATM, because again, in PV equals nRT, we gotta have ATM, all right? Which would be 1.0 something, right? 1.0105, so we'll just go 1.01, that's plenty, because we only had 3 sig here, I'm happy. All right, now we solve our equation for V, PV equals nRT, right? PV equals nRT, solving for V would just be V equals nRT over P, and then you just plug and chug.
What's R?
R is the gas constant, was 0.08206 liters mole over, liters ATM over mole Kelvin. All right, does that make sense? So we only using stoichiometry to get the number of moles. Once we have the number of moles, we plug it in.
And you get your answer in liters, right?
Yeah, your answer is in liters, so if they ask for milliliters, you would just multiply it by 1,000. All right?
It's 10.0802.
So then we could get like
That's all ours.
60
Oh, R is
milliliters.
0.08206, I
got
think.
60.3.
Milliliters?
Oh, yeah.
Is it milliliters or?
I
Oh.
got the
Or
multi-
is that liters?
Well,
Well, that's just like the equation put in, that's like the, like, NRT over B, that's just what
I got
Okay.
61,050.
So you got 61 liters? What'd you get, 60?
60.3 liters.
You're gonna make me do math.
I kept 3 sig figs for three on everything else. So I went to 2.53.
Oh, there you go.
But Lucy
That
did
would
that
change
too.
it just a little bit.
Lucy did that too.
Oh.
All right.
I did 2.5, because I was looking for it.
Okay, so 76 times 2 divided by 60. Okay, so 2.53. All right, either way. All right, so 2.53, I'm just going to use that one just to see, times 0.08206 times 297 equals divided by 1.01 equals. So yeah, you get 61
Okay.
liters multiplied by 1,000 would be 61,050,
100.
right?
Well, 1,000.
I got
Or
59.
100. Because you'd have to do 360.
Oh yeah, 61,100. What?
I got 59 liters.
Did you just use 2.5 instead of 2.53, which is fine?
Oh, yeah.
2.5 times 0.0 times 294 divided by 1.
2.4.
Or 297, that's right, we're 297 times 0.08206 times 2.5 equals divided by 1.01. I still get 60.3.
David, are you leaving every number in your calculator, not like rounding?
It's
I
a-
put 0.08026.
No, 0.08206.
Okay. And I also put the 1.15.
Yeah, that would give you a little more, or yeah, a little more. So,
Okay, that
all right.
makes sense.
Any questions on that? That's just stoichiometry.
That was pretty easy.
All right. Yeah. No. Okay. So again, you might have to go to You might have to find density.
Wait, can
You might have to find density using PVRT equals nRT. Remember, and there was I think we did some practice problems with this. For that N is the mass divided by molar mass, right? N is mass divided by, so then if we have PV equals mass over molar mass RT,
It'd be P.
density is mass divided by volume.
So it'd be P molar mass over RT.
Yes, so we'd have P molar mass R over RT, right?
When it says particles,
Like molecules.
molecules,
6.02 times 10 to the 23rd. M over V equals P molar mass over RT is mass over volume, which is density.
Wait, so N is mass over volume mass?
Yeah, that's how you find the number of moles, right?
Yeah.
If I give you a mass, you find the moles by dividing by the molar mass. Right. Oh, good. Oh man, I have like 15 copies of this thing. All right. Yeah, so that's the only weird ones. I think there's another couple just PV where you have to solve for something here, but particles, density, and stoichiometry. All right. There is a PV equals nRT where you have to do partial pressure. Remember, for PV equals nRT, you just need the total number of moles, right? Yes. Okay. There's another partial pressure like I was showing you the other day how to do, where you're collecting a gas over water, where it's P1 V1 equals P2 V2. P1 and V1 are the conditions they give you. P2 is the pressure after you subtract out the vapor pressure of water and you solve for V2. Okay? Effusion rates, all right? You might have to do something with rate or with molar mass. So make sure that, I think they give you that equation, I'm not sure, but make sure you remember that equation, right? The rate, am I on the screen? Yeah. Rate of A over the rate of B,
Square root of the molar mass.
yep, is the square root of molar mass of B over square root of the molar mass of A. Okay, so if you have to find, if they give you everything but the rate, right? If you know the rate of one and you know their molar masses, you can find the rate of the other one, just plug and chug. If you're trying to find the molar mass and you know the ratio of the speeds, you can find it. That's what I showed you how to do that the other day, okay? But it's just plug and chug, guys. This is, honestly, manipulating these equations like this, it's really algebra. It's like really algebra 1. It really is. So that's what you need to do.
That's not root mean squared, is it?
No, but it's related. So root mean square, if you remember, RMS, am I on the screen? Is equal to square root of 3, is it RT?
Yeah.
Over M, which is the mass or molar mass.
Kilograms.
In kilograms, so that's a key thing. This has to be in kilograms, and this is the other R. They give you both R's. They give you both R's. You use the, yeah, it's 8 point something, whatever it is. All right, and this is the one that is joules over,
Over kilogram, or over, moles over,
is it?
moles of, yeah.
Joules over moles Kelvin, yeah. Instead of liter ATM, okay? Because we're using the one where we're using joules instead of pressure.
So what is that solving for again, the root mean squared?
That's the velocity.
Oh, I thought that, no, fusion is how the rate of fusion.
Rate of effusion is this one. This is Graham's law. Oh, sorry. This is the Graham's law one. This is for the velocity of something. All right? Yep. Okay. And then the other part is know what conditions do we have to treat gases as if they are not ideal, right? And you need to know that. That's a
Isn't it high pressure, low temp?
high pressure and low temp, yeah. High pressure and low temp. And particularly high pressure with small volumes and stuff like that. All right, now, a couple of remembers. Remember, and I can't spell member. All right, remember temperature in Kelvin. But if you have it in kelvins and they ask for Celsius, change it back. I'm not sure whether they do or not. I'm just telling you. Check your unit. Always match your units to your constants. If they give you the pressure in something other than ATM, make sure and turn it into ATM before you put it into PVNERT. Okay? All right? And then the only other type of question is you'll have to order different molecules from slowest to fastest. And remember, what goes fastest? Little or big?
Small.
Little. Yeah, little goes fast, big goes slow. Think of Corvette versus dump truck. Corvette's going to win in a race, dump truck's going to win in a brawl.
Is there an exception to that?
Is there an exception to it? As long as they're at the same temperature. I mean, that's what we're talking about here. At the same temperature, smallest, faster, or biggest, slowest,
Why
right?
do you need to remember temp and Kelvin again? I mean, for everything, but.
Because if you don't, remember when we were doing those practice problems and stuff, if you leave the temperature in Celsius, the ratios are off.
Well, no, I mean, for what problems is there? Remember?
Oh, anytime you're doing like PVNERT, or if you're using a Charles Law or any of those, anytime you're doing a variable that has temperature in it, make it Kelvin. make it.
I thought you had like a specific problem in mind with that.
No, I haven't even looked to see if they do that to you. But if they give you the temperature in Celsius, just write it down in Kelvin. All right? Okay. I'm gonna